Welcome to the series of database management system video lectures. Today we'll be discussing about unit 3, topic 5, that is concurrency transaction processing and then concurrency control problems. Let us look at concurrent transactions. In the previous video, we have discussed about what is a transaction and what are the various states of transaction which undergoes. So there in that context, we have discussed about taking only one transaction. Now let us see how transactions can take place at the same time. Now T1 and T2 are two transactions which are executing simultaneously. Right? So we have data member A with value 100. Now in the first step in transaction T1 is you are reading the value of A. So by this statement, it will get the value as 100. Now transaction T2 has also access to the data member. It is also attempting to read the value of A, which will get 100. Now the second operation in transaction T1 is we are modifying the value of A, expecting it to get 50 here because we are deducting that. Now by the time T2 transaction is not performing any operations. Now look at the transaction step number 3 here. Now we are writing this value into the database. Whatever the changes that we made here, it is going to be reflected here as 50. Okay. Now, soon after you are updating the value, now T2 transaction is adding the value 100 here. Now it is assuming that 100 plus 100 is happening, and that's how I'm expecting to get 200 here. Now, at third statement, you have already written. Now at fourth statement, you are printing the value of A. So in fact, it will get the value to be 50 here. Now look at the value of, look at third step in T2 transaction. It is updating the value now. So when we update it, already we have 50. So 50 plus 100 it is happening. So it will get 150 here. Okay. It will get 150 here. But in fact, we are expecting 200 to get, which is not happening. So when you print it also, you will get 150, which is not the correct one. So when multiple number of transactions are acting upon the same data time with respect to timestamp, which operation has executed at what point of time will be given high priority, and the operation which is taken here, write operation and commit operations, will be more important for accessing to the data members with modified values. So now dealing with concurrent transaction processing may sometimes lead to data inconsistency. Okay. So now already at this point of time, it has written A, which is expecting to be this, but then when this transaction T1 is attempting to read the value, it will get 150. So now there is an inconsistency that happens because the data was not integrated with respect to the ongoing operations. Right? Data integrity is also lost, which in turn the data performance, it will also have a very bad impact upon it. Right? So when dealing with multiple transactions, a lot of care should be taken so that we will never compromise with the quality and the performance of the database, and data should be integrated, and that's how the consistency of the database system should be maintained. Right? So now, while dealing with multiple transactions, we need to face many issues. So what are the problems that are encountered while dealing with multiple transactions? Let us look at here. So these are the concurrency problems that happens while dealing with multiple transactions acting upon same data members or multiple data members. The first one is lost updates. Now look at here. When we are modifying the value and when you are expecting, now at this transaction T2, at step number 2, you are updating the value to be 100, but in fact the value of A is not actually 100 because it has been modified by transaction T1 at step number 2. So it is called as lost update. Whatever the value which you assume it to be is no more available, but it is being modified by the other transaction. That is what called as lost update. Now the next one is temporary or dirty read. Now the changes have been taken place in the data in the address, and now at a transaction T1, when you are attempting to read the value of A, which has been modified to 150. Earlier, when you read the value, it was 100. Due to the modifications, again, it has been changed to 150. So this is what called as temporary or dirty read. The data has been manipulated by some other transaction without awareing of the transaction T1. So which means that we are expecting T1 transaction to execute independently and T2 transaction should execute independently. This inconsistency should not be entertained. Right? Whatever maybe the data manipulation things that are happen in T1 should be reflected to only T1 transaction. It should not have an impact on the other ongoing transactions. So all these transactions should execute in isolation, right? That is again another property of the asset properties which have to be adhered by the transactions. Now the third one is non-repeatable or fuzzy read. Now every time when you are accessing to the data value of data member, for the first time when you are accessing, you are getting the value as 100, and the next time it has been modified. If my own operation is being done, then it can be acceptable. But then if it has been modified by any other transaction and getting the undesired result, it's called as fuzzy read. And the last one is phantom read. And the last one is phantom reading. So in phantom read, while starting with the T1 transaction, it assumes to be the data values are 100. and later on it is continuing by keeping it in the point that value A has 100 and continuing with other operations. But in between, T2 transaction has modified the value, and this is without aware of to T1, and then continuing further expecting with some other value, right? So this is what called as phantom rate. So these are the four different concurrency issues that happens dealing with concurrent transactions execution in the database, right? So to overcome with this, we need to go with a schedule. What do we mean by schedule? Schedule with respect to the timestamp, the operations are going to be taken place. Now we don't want multiple transactions to be executed. Multiple transactions, concurrency of transactions gives many advantages. The first one is that the throughput of the system is improved. That means the number of programs or the transactions that are executed at a given timestamp within a given time slice are going to be increased. Second one is that the response time, the average response time is also going to be increased. And the third point is that the CPU time is going to be utilized in a greater extent or in an efficient manner. So all these are the advantages when we go with concurrency of transactions. Because when we don't go with concurrency of transactions, we need to wait T1 transaction to get it done, and only then T2 transaction will start doing it. And once T2 transaction has completed, only then T3 transaction will be taken place. So in that case, let us say that 2 seconds of time will be taken for every transaction. So on the whole, it may consume 6 seconds of time to finish only these 3 transactions if we go with a single processing system or single transaction system. Now, if we wanted to improve the usage of this, we need to perform concurrency of transaction. How this can happen? T1 has started, it may take 2 seconds of time. By the time T1 has finished 1 second of time, T2 has entered. It again needs 2 seconds of time. So here at the 0th point, it has started at 1 timestamp, it has started T2. And then by the time T2 has entered into the next second, T3 transaction has started. So T3 has started and it may take 2 more seconds of time. Now, when we look at on the whole, at a 0th time it has started. By the time 1 it has reached, T2 has started. So here for T2 plus 2 more seconds. And again, T3 has started. Okay. And then by the time it reaches to 2, T3 has started. So 2, 3, 4, 5. So within the time slot of T1 transaction gets completed, T2 and T3 are going to finish their 1 second of time. Right? So you may reduce. Here you may see that only 5 seconds have been used for finishing the 3 transactions by overlapping one with other. But when you consider hundreds of transactions started at a difference of nanoseconds of time, then it will have a lot of impact upon the throughput of the system as well as the execution time. Okay, so that's the reason we should design our database in such a way that to support even the concurrency of the transactions, right? So now to deal with this and to overcome with the concurrency problems, we need to design our execution of transactions in such a way that it should not have an impact on the outcome. Now look at here. We have taken a schedule. Schedule here is nothing but a series of operations that are undergone by T1 as well as T2 or multiple transactions. Now, at what point of time? Yeah. Now look at the schedule T1. Now T1 transferring $50 from A to B. So now T1 is one transaction, T2 is another transaction. Now T1 is attempting to deduct the value 50 from A to B, and T2 transfers 10% of the balance from A to B. Okay, again it is impacting upon A, okay, and then it is transferring to B. Now, when we start this series of schedule, T1 at step 1, it is reading the value of A, which will get as, assume that A has 100 earlier, A has 100, so it will get 100 here. Now, A is deducting, so it is get 50 here. Now, we are updating that, so A will have 50 here. Now, we are reading B value. Now, assume that B has 100. Now, you are reading B, so you'll get 100 here. And then you are changing the value of a B to be B plus 50, so you will get 150 here. And this 150 is also updated in the database, right? And then you have issued commit. So which means that these values are preached. A will have 50 and B will have 150. So these are the values which are preached. Now, by the time it gets finishes, 4, 5, 6, 7. So let us say that 7 seconds of time has been taken, 7 nanoseconds of time has been taken to finish transaction T1. And then at 8th second onwards, T2 transaction will come into the picture. Now it is reading A, it will get 50 here. And then in a temporary variable, we are calculating the percentage, 10% of value A. We are calculating 10% of A. So A has 50 into 10%, right? So which is fine. So 50 minus 5 will give you 45. Right? So this is A. 10% of A is fine. So this 5 is going to be deducted from A, that is 45. So at this point of time, you will have 45 and you are updating this A value. So in the memory, you will have 45 here and then you are reading B. B will get as 150 and then you are updating the value. 150 plus temporary value is 5, 155 and you are updating that in the memory. That becomes 155 and then you are issuing it. So this is going to be freezed. So this value is no more and this value is no more and this is freezed. So now 8, 9, 10, 11, 12, 13, 14, 15. So how much amount of time has been taken for executing T1 and T2 transactions as per the schedule 1, that is 15 nanoseconds of time, because these are independent. Let first T1 transaction start and then let the T2 transaction start it later. So that's how it has taken 15 nanoseconds of time to finish this schedule 1. Now look at schedule 2. Now let all the operations of a T2 is done first and then T1 is carried out later. Even now also here it will take 15 nanoseconds of time to finish this, because we are not going with concurrent or parallel execution of both of the transactions. That's the reason. Now look at schedule 3. Now the schedule 3 has been designed in such a way that to reduce the overall execution of the time for these two transactions. Now T1 transaction started with A. Now A will get 45 here and then this value is being deducted. Why this sort of thing have been done here is to achieve, this is sequential or a serial transaction execution. This is also a serial transaction execution. One after the other is happening here. One transaction, let it complete it and only then second transaction can take place. So schedule 1 and 2 belonging to serial transaction execution. Now look at the third schedule. Here, two transactions have started. T1 has started and then at certain point of time, T1 has stopped and T2 has started. And at certain point of time, T2 has stopped and T1 has started. And then T1 has stopped and then T2 has started. So now here, multiple transactions are taking place simultaneously, but not at the same time stamp. So which means that these two can isolate the values. Both are isolated with each other. That means T1 transaction can execute independently and T2 transaction can execute independently without interfering into T1 and then T2, right? So now this is called as concurrent execution of transactions, which will definitely reduce the total amount of time, total execution time. Now look at schedule 4. Here also, we are performing the concurrent execution of the transactions, but the values are getting, the incorrect values are being accessible here, and we are preserving, we are trying to preserve the values so that it will not have an impact upon the other transaction values, right? Let us look at schedule 2 and 3. In schedule 2, there is no difference. The same set of operations are being done. So you will have the same values, that is 45 and 155. So here, first A read A minus 50, whatever the value which you got, A to be 45. We will retrace it out. Now, A is earlier 100 and B earlier as 100. Both are 100 we have taken. Now, reading A, here you will get 100 and A minus this is 50 and you are updating. So, A is going to be 50 now. And then your reading value of a B, you will get 100 here. You are adding 150. Now, you are writing that. So, it becomes 150. It has updated and then it has freezed. So, this is the values for, with respect to T1. And then with respect to T2, look at the timestamp. First T2 has started and then T1 has started. So, first let us assume that T2 has started. So, you are reading 100 here. And the percentage is calculated, which you will get it as 5. And you're deducting that, it gives 45. And you're updating that. So in A, you will get 45. I'm sorry, earlier A is 100 here. B as 100. So now A value is calculated. And then we are writing that A value as 45 updated and reading value B, which is 100. And then B value is added with a temp value, that is 100 plus 5. 1% is 10 here, 100. Yeah, it is 10 here, not 5, 10 here. So deducted 100 minus 10 will give you 90. So A will get 90 here. And then B, we are taking 100. And then B plus temp, temp has 10 now, 110. Now B will have 110 now. A will have 90 here. Okay, after the updations. So these are the values which have taken. And upon this data value, now T1 transaction will take place. So A is taken as 90 and B is taken as 110. Okay. According to this, these set of transactions will take place. So with respect to schedule 1, if T1 has taken first, these are the values. And if T2 has taken second, then this is how the values are going to be reflected. And in schedule 2, if T2 has started first, these are the values for A and B values, A and B variables. And later T1 has acted upon it, then the values are further changed according to this requirement. Then look at the schedule 3, wherein simultaneously it is happening here. you're reading A value. A value has been further changed to, no, here we will take it as a separate one. A has 100 and B has 100. Okay. Now A, here it will take it as 100, deducting, so it will have 50 here. And then you are updating that. So A becomes 50. And then immediately T2 transaction has started. So here it is reading A, that it will be 50. And you're calculating 10% upon A, which will be 5. And then we are deducting that. So it becomes 45. And you're updating that. So now this becomes 45 now. And then T1 transaction has started. It is reading B value. And then B plus 50, it will get 150. 150 by this here. And you're updating that. So it becomes 150 here. And then you're committing, you're freezing. So you're freezing the value of B. Okay. Next, T2 has started. Now T2 will get the value to be 150. And then you're adding the value with a temporary. That will be temp has 5 here. So 150 plus 5 becomes 155. And then you are updating this B value. It becomes 155 here. And then you are freezing this. So this is how when it has taken parallelly 45 and 155, you will get here there is a change. And look at the schedule 4. Again, take A as 100 and B as 100. Now you're reading A, which will get 100. You're deducting, you'll get 50. And then T2 has started. T2 is attempting to read value of A, which is 50. And you're calculating 10% of it, which gives you 5. You're deducting that, it becomes 45. And then after deduction, you're writing the value. So A becomes 50 earlier. Okay. And then this again further changed to 55. And now you're reading B, which will give you 100 here. Right. And then again T1 has started. You're writing A. Now you are expecting that this change should take in place. Right. You are modifying this. So it is expecting A value earlier was 100 and you're deducting 50. And then this value you're expected to be updated in the database. But in fact, the change has been done with the T2, right? So this is what called as not isolated. There are no transactions which are happening independently. So which will have an impact upon the data values. So these are the concurrency issues that happens when multiple number of transactions come into the existence. To overcome with this schedules, we need to either serialize the data and then we may overcome with the problems and then we can recover. If any changes that have been made to the data member, you can recover it back, right? Thank you. That can be discussed in the next session.